So now we're going to look at function calls with recursion. Okay, function calls with recursion. So we're going to have a function A, similar to our previous example. Function A, again, has some lines of code and it assigns to x. But this time, instead of assigning function B to x, we're going to assign the return of function A to x. Okay, function A has some more lines of code and then it returns a result. Now this is a recursive function because function A is calling on itself. Now within this function A we have a call to x equals function A, and so this function A is a call onto itself. Okay. Now this can be a little difficult to understand and conceptualize. So one way for us to conceptualize this a little differently is to think, instead of function A calling itself, even though that is what it's actually doing, we can think of it as calling a copy of itself. Okay, think of it as calling a copy of itself. So I'm going to make a function A prime, and then this we'll get rid of. Okay, and we'll say instead function A is calling a copy of itself. Function A prime because it is the same exact code as function A. We'll say the exact same thing, and it'll again return a result. And this function A, within this call to function A, within function A prime, we'll also call function A. We'll also call function A. This time we'll call function A double prime. Also have some code, and then x equals function A, and then it'll return a result. Okay. So, if this is our function, we can kind of see what's going to happen. A is going to call function A prime. Function A prime will call function A double prime, which will then call itself it again. So this really goes until infinity. Function A just continues to call itself into infinity. And while this may be a recursive function, it's not a particularly useful recursive function for us. And that's because it never gets to return a result. This portion of the code here, this never runs. Okay? Because once function A reaches this line of x equals function A, it goes off into calling this copy of function A prime, and this code never runs because it never gets a chance to evaluate and finish running this line of x equals function A. If we were to put it in box diagram form, it might look something like this. Function A calls itself into infinity. Okay? Now, if we want this to be a more useful recursive function, what we really need is for function A to be able to evaluate at some point and return a result without calling itself again anymore. So we need something in box diagram form that looks like this. Function A calls itself function A prime, which may call to function A double prime, which was previously calling to infinity, but that no longer happens. Instead is able to evaluate, return a result, and return a result again, which allows function A to return a result. Okay, something a little bit more similar to our function A calling function B calling function C example. So the question becomes, how do we make this happen? How do we make this recursive function useful by breaking the infinite cycle? So we can do this by adding a few things here, okay? So I'm going to go ahead and add a few things to our code here. The first is I'm going to add a parameter of n. Okay, we've just been using function A in general. Now I'm going to add a parameter of n to function A. And then when function A calls on itself, instead of passing the parameter of n, I'm going to pass the parameter of n minus 1. Parameter of n minus 1. Okay? And then the last thing I'm going to do is this section here, I'm going to replace it, okay? I'm going to replace this section of code with if n equals 1, return 1. Okay? If n equals 1, we're going to return 1. Okay? This section of code is called a base case. Base case. Okay? And so what's going to happen is, first we're going to assign here, let's say that n, for example, equals 3 here. Okay? Then when function a calls on itself, it's going to pass n minus 1, which is 3 minus 1, which is now going to be n equals to 2. Okay, and then when this gets passed through, function a prime calls itself, it'll pass 2 minus 1, so it'll pass 1 to this value of function a for n equals 1. Now, because n equals 1, we are able to hit this condition of if n equals 1. Okay, because this n equals 1, we're going to run this block in the if statement, which is to return 1, which is what we're calling the base case. So therefore, this value gets returned. Since this value gets returned, it's able to evaluate, it's able to return a result, which gets passed back to here, which is then able to evaluate x here. This code is now able to run, so it's no longer never runs, because it's able to run now because x was able to evaluate to something, and we're able to calculate a final result. Okay, so I want to run through this one more time, because this is really, the pieces I just added are really the heart of what recursion is, and things you need to remember when you're writing recursion. Okay, so I'm going to go ahead and write a summary of these important points of recursion. Okay, the first is that in a recursive function, it calls itself. Okay, it calls itself. So function a calls itself here in x equals function a. Okay. Other point to keep in mind is that we have a base case. Okay, we have a base case. Okay, so this thing, if n equals 1, return 1, it's a base case. And the definition of a base case is that there is some state of n, some parameter, where when the recursive function continues to run, it eventually reaches a point where it's able to evaluate and return a result without calling itself again. Okay, so in this example here in function a prime, right, we hit this line of code, and for a function a prime to evaluate, it must call itself again. But when we reach function a double prime, because n equals 1, we're able to satisfy this condition clause, and this condition clause states that we simply return 1, and therefore this section of code right here, this does not run. And this section of code is where function a double prime would normally be calling function a triple prime. But because we've reached the base case, this section of code doesn't run, and we're able to return a result. Third is we have to make progress towards the base case. Towards base case. Okay, this is also very important. It's not enough that we just have a conditional statement that's also going to return something. As function a continues to get called, it has to get closer and closer to the base case. So in this example, n is initially 3, but then when function a calls itself, n gets decremented to 2, and then gets decremented to 1, so that we get closer and closer to the base case. If we had put n plus 1 here, such that when function a calls itself, it says x equals function a of n plus 1, then this would be 3, but this would be 4, and this would be 5, and we would never reach our base case of 1. In which case, our function would still run until infinity, and we would still never be able to evaluate to a result. Now similarly, if our base case had been different, right? If our base case had been n equals 10, right? Then this would probably actually have to equal n plus 1 or something additive, so that 3 could then get turned into 4, 5, 6, 7, 8, 9, 10 until we eventually reach the base case. So the base case doesn't have to be n equals 1, and you don't necessarily have to decrement when calling the function itself again. But you do have to make progress towards that base case as the function calls itself recursively. Okay, and the fourth point is that we have different ends. Okay, we have different ends, and that's because we have to keep in mind that function a is a different scope than function a prime. Even though it's the same code, and you're writing it just once, when you're writing this function, you're only writing this portion, that first portion. Okay, even though you're only writing the code once, when it calls itself, that new call on itself is considered a different scope, which is a new playground, and which means it has its own memory, its own variables, and its own values. So we have to make sure we keep that in mind where n is 3 here, but here n is 2, and then here n is 1.